Hey everyone, welcome back to part 4 of our Java interview questions series. In this episode, we're diving deeper into core object-oriented programming concepts, things like the object class, access modifiers, method overriding, encapsulation, and polymorphism. These aren't just textbook topics, they come up all the time in interviews. Mastering them will give you a serious advantage. So grab your notepad, make sure you've subscribed, and let's continue getting interview ready with Java. Let's start with one of the most fundamental concepts, the object class. In Java, the object class is at the top of the inheritance tree. That means every single class, even the ones you write, implicitly extends the object class, whether you mention it or not. It also gives us some commonly used methods like equals, for comparing objects, hashcode, for generating hash values, and toString, for string representation. There are also methods like wait and notify, which are powerful tools when dealing with multithreading and synchronization. Next up, access modifiers. These are like gatekeepers in your code. They help you control who can see or use a class, method, or variable in your program. Java has 4 main types of access modifiers: public, protected, default, no modifier, and private. Public means it can be accessed from anywhere. Private keeps it locked within the class. Protected gives access to subclasses and classes in the same package. And if you don't specify anything, that's called default access, which restricts access to the same package only. Using access modifiers correctly is key to writing clean, maintainable, and secure Java code. Let's break down access modifiers with this visibility table, so you can see exactly where each one applies. At the top, we have public, it's the least restrictive. You can access it from the same class, same package, subclass in another package, or even from completely unrelated classes. Next is protected. It allows access from the same class, same package, and also from subclasses, even if they are in different packages. But not from unrelated classes in other packages. Then there's default access, also known as package private. This one only allows access within the same class and same package. If the class is outside the package, access is denied. Finally, we have private. This is the most restrictive, the member is only visible within the same class and nowhere else. As you move from public to private, the level of visibility narrows down. Knowing when to use which modifier is key to good object-oriented design and information hiding. Now let's talk about one of the most important concepts in OOP, method overriding. Overriding happens when a child class redefines a method inherited from its parent class, using the same name, return type, and parameters, but with a new implementation. It's a way to customize or change behavior that was defined higher up in the class hierarchy. Let's look at a real-world example, the equals method. In the object class, it simply checks if 2 references point to the same object in memory. But the string class overrides this method to compare the actual content of the strings instead of just their memory reference. This is what makes str1.equals str2 work as expected when comparing 2 string values. So, method overriding gives you the flexibility to modify inherited behavior to suit your subclass's needs, one of the key principles of polymorphism. Before you start overriding methods, there are a few important rules you need to remember. Rule 1, you cannot reduce the visibility of the overridden method. So if a method in the parent class is public, it must remain public in the child class. But you can increase visibility, like changing protected to public. Rule 2, the method signature must match, that includes the method name and the parameter list. Even a slight change means you're not overriding, you're overloading. Rule 3, the return type should also match, but there's an exception, you can use a covariant return type. That means the return type in the subclass can be a subclass of the return type in the parent. Following these rules is essential to ensure that overriding works as expected, and avoids confusing bugs or compile time errors. Let's talk about encapsulation, one of the core pillars of object-oriented programming. Encapsulation simply means wrapping data and behavior together inside a class. It prevents direct access to the class's internal state. For example, we use private fields to hide data, and then expose them safely using getter and setter methods. This way, you control how data is accessed or modified, adding a layer of security and maintainability to your code. In real-world code, this helps you prevent unwanted changes and maintain a clean contract for working with objects. Now let's dive into polymorphism, which literally means many forms. In Java, polymorphism lets you write code that works in multiple ways, depending on the context or object type. There are two types you need to know. One is compile time and another is runtime that we will look in next slides. Let's start with compile time polymorphism, also known as method overloading. This happens when a single class has multiple methods with the same name, but different parameters, either in number, type, or order. It's called compile time or early binding polymorphism because the Java compiler determines which method to call during the compilation phase. Take this example, a calculator class with two add methods. One takes 2 integers, the other takes 3. Based on the number of arguments you pass, the compiler decides which version to execute. This improves code readability and makes it easier to work with related behaviors using a consistent method name. Now let's look at runtime polymorphism, also called method overriding. This occurs when a child class provides its own version of a method that's already defined in the parent class. Unlike overloading, this decision is made at runtime, meaning the JVM decides which version of the method to execute based on the actual object type, not the reference type. For example, here's a calculator class with an add method. Now, advanced calculator extends it and overrides the same add method, but with extra logic. If you call add on a calculator reference pointing to an advanced calculator object, Java will run the overridden method in the subclass at runtime. This is a key feature of polymorphism, allowing you to write more flexible, extendable, and dynamic code. And that wraps up part 4 of our Java interview question series. Today, we explored some of the most important object-oriented concepts, including the object class, access modifiers, method overriding, encapsulation, and polymorphism. Mastering these topics will definitely give you an edge in interviews and help you write more structured, maintainable Java code. If you found this video helpful, don't forget to like, subscribe, and drop a comment below with any doubts or concepts you'd like me to cover next. Hit the bell icon so you don't miss part 5, where we'll continue preparing for Java interviews with even more core concepts and coding patterns. Until next time, keep coding, keep learning, and all the best for your interviews.